Welcome to Part 7 of the Guided Tour series. In this section, we will define the top-level behavior in an FFBD view and add inputs, outputs, and triggers in the Nsquared diagram. We have already worked through capturing requirements and defining the system boundary and architecture restraints. We're ready to progress to deriving system threads. At this point, we begin the behavior analysis of our system. We will do this graphically by building an FFBD of our context function, Autolink functional context. Core's FFBDs have the classic features of logic structures and functional decomposition. The logic constructs allow you to indicate the control structure and sequencing relationships of functions. If you prefer SysML representations, you can complete this portion of the guided tour in an activity diagram. In the element browser, select the function element Autolink functional context. Click the FFBD icon to open a functional flow block diagram of the selected element. Select the branch between the two reference blocks. This is where we will insert the functional behavior for the context function, the root function for Autolink context. Reference nodes indicate the source and sink of control flow, or what function completed immediately before this flow begins, and what function will be enabled when this flow completes. Since there is no source or sink for the Autolink functional context, functional flow, the reference node is labeled REF. We have 5 functions that we want to include in our diagram: perform Autolink functions, perform client functions, perform emergency response functions, perform GPS system functions, and perform vehicle functions. Each of these functions works in parallel. To incorporate these functions into our diagram, we will create parallel branches. From the FFBD window, click on the parallel and icon to insert a concurrency structure. Core prompts for the number of branches. We will create a concurrency with 5 branches since we have 5 functions, so at the prompt, type 5 and click OK. Now we insert one function on each branch. Highlight the top branch. In the FFBD window, click the Insert Element icon to open an Insert Element dialog. The Insert Element dialog works like the Edit Targets dialog. It shows the elements that can be inserted. You can select from existing elements or create new ones. From the list of elements, select Perform Client Functions. Click Add to add it to the Selections pane, then click OK. The selected function element is added to our FFBD. Now, pause the video and in the same manner, insert Perform Autolink functions on the second branch, perform emergency response functions on the next branch, perform GPS functions on the following branch, and perform vehicle functions on the last branch. Now, let's add inputs and outputs to these root functions, and thereby to the components that they are allocated to, in order to show the interdependencies of the functions. We will do this by using the Nsquared diagram. An Nsquared diagram shows the data flow between functions. In a later exercise, we will show how to add data flows in an eFFBD. First, close the FFBD window. Click the Nsquared tab at the bottom of the screen to open an Nsquared diagram of the function Autolink functional context. The Nsquared diagram displays the data dimension of the behavior model, whereas the FFBD displays the control dimension of the behavior model. Used in conjunction with an FFBD, the Nsquared diagram helps to capture and analyze the functional behavior of your system. Items represent the information that flows between functions. An item is input to, output from, or triggers a function. On the Nsquared diagram, click on the icon Perform Client Functions. The first element selected is always the function whose output from relationship is being set. Now, while holding down the Shift key, click to select the Perform Autolink Functions icon. The shift-clicked second element is always the function whose input to, or triggers relationship is being set. Click on the Connect via Trigger icon. This opens a connection dialog. Because we currently have no items in our database, we'll need to create one. Double-click on the item folder to open the New Item dialog. Type in Client Information Request and click OK. The Client Information Request item is added to the Nsquared diagram. Notice the direction of the arrow. The Client Information Request is output from Perform Client Functions and triggers Perform Autolink functions. We'll now add 3 additional data items in the same manner. Pause the video and, using the table on screen as a guide, complete the model by adding these additional items and their flow between the functions. In an Nsquared diagram, the functions appear on the diagonal, and items are shown off the diagonal. For a specific function, all input items are located in the function's column. All output items are positioned in the function's row. Click on the idef0 diagram tab. We are now viewing a function decomposition using the idef0 diagram. The idef0 diagram is derived from the functional decomposition inherent in Core's behavioral models. It enables users to view the functional decomposition and identifies the inputs, controls, outputs, and mechanisms associated with each function on the diagram. Thus, Core provides automated idef0 diagram support for customer reviews, and each idef0 diagram is guaranteed to be consistent with the underlying behavior model. The idef0 diagram is a partial subset of the EFFBD. The idef0 diagram does not show control constructs and therefore does not show sequencing. This concludes Part 7 of the guided tour. Part 8 will add the next level of detail to our functional decomposition. If you have any questions or concerns, let me know. Email me at support@vitechcorp.com.